Hey everybody, Phil Zito here, and welcome to today's live stream. So in today's live stream, we're going to be talking about controller hardware types. So what we'll be covering here is we'll be talking about the four-tier building automation architecture, which is the most common architecture you are going to experience. And we're going to be talking through kind of how do the different controller types work within that architecture. So I'm going to grab some markers and go over to the whiteboard. All right. Let's just grab right here. Black and blue. Okay. All right. So if you're not familiar with a traditional four-tier architecture, what the four-tier architecture is that you have a server, a supervisory device, field bus, field controllers, and then inputs and outputs. All right, so we're going to have a server, which we're just going to call SER. That server is going to go to a network switch, which we'll just call SW-1. That switch is typically going to go to a supervisory device. And then that supervisory device is going to have a field bus that is going to go to controllers right there, okay? Now there's several different parts and pieces here. So if you are engineering a system and you're looking at the system and you're like, okay, what parts and pieces do I put in which place? How I like to approach this is I start off by working on what are called application-specific controllers. So these are specific to applications. And these can be unitary controllers, or these can be actual like VMA controllers, or they can be things like packaged unit controllers, things that you're going to integrate. So your primary focus here is going to be looking at those controllers, because those are often the most plentiful controllers within the building. If we're thinking of terminal units, fan coils, packaged rooftops, those are the most common and most quantity-wise controllers that we're going to find. So we'll go and address those application-specific controllers. Then, once we've addressed those application-specific controllers, we can get to advanced application controllers. Now, advanced application controllers, these are controllers that are usually used for plant control, for built air handling unit control, and they have greater capabilities. Now, some of these will be BACnet IP, some of these will be MSTP. Most of the advanced application controllers nowadays are BACnet IP. So we're going to go, like I said, we're going to focus, actually I'm going to use blue for this. So we're going to focus on ASCs and then AACs. So once we've got those two things figured out in our bill of materials, then we're going to go and we're going to focus on our building controllers. Now, building controllers are also known as supervisory devices. And originally, the purpose of a supervisory device was to take serial networks, supervise those networks, and convert those networks into data flow that could be ingested by, at the time, thick clients, nowadays thin clients. Supervisory devices capabilities have expanded way beyond that, in that now they allow visualization of data, trending, data analysis, some global level programming. So whereas oftentimes in ASCs you'll do configuration, although some of them are free programmable, AACs are almost always free programmable, but they also have some building controller capabilities. Now we'll talk a little bit later in this live stream about a three-tier architecture that uses AACs in lieu of BCs. So a BC, a building controller, is going to be your supervisory device. Now these can be in hardware format, or they can be what are known as software supervisory devices. You're seeing a lot more software supervisory devices now that we are seeing more BACnet IP enabled controllers entering our architectures. So the supervisory device is going to connect to the field bus. Field bus is typically going to be some form of RS-485. So typically BACnet MSTP, sometimes LAN FT10, very rarely Modbus RTU. Now I know LAN FT10 is not really RS-485. It's kind of its own little standard as far as wiring goes. Now the supervisory device and the building controller is going to go to the Advanced Workstation, typically. So an AWS or a BACnet workstation or an operator workstation. There's a variety of acronyms. There's a variety of BACnet profiles. There's a variety of types. But the purpose of the server is to take multiple different supervisory devices and consolidate them into one frame of reference, both from a visualization perspective, which is its primary purpose, as well as from a data logging perspective. So supervisory devices, right, they can have visualization. Now the problem begins where you have multiple supervisory devices in a site, and because of having these multiple supervisory devices, in order to see the multiple different visualization suites that are going on, like, okay, floor 1 is covered by supervisory device 1. Floor 2 is covered by supervisory device 2. So in order to see these different graphics, you have to go in between the different supervisory devices. So servers enable you to have a single graphics environment. You don't have to switch between supervisory devices. They also enable long-term trending. They also enable APIs on some software. So there's a variety of things. Now let's talk about kind of micro architectures, which are 3-tier architectures, and there's really 2 types. There's a IP microarchitecture and a non-IP microarchitecture. Now, a non-IP microarchitecture would simply be the supervisory device and the field controller and the I/O. That would be the 3 tiers, right? You'd have supervisory device, you'd have a serial network going to your field controllers, and then you'd have your I/O. This is very common of commercial office buildings where maybe you have a supervisory device or you have an advanced application controller, and you have those actually sitting on maybe a rooftop unit, and you've got like 20 VAV boxes, and that's it. That's all you got. That's a very common architecture. You don't need a server for that unless like you need the data logging capabilities of server, which is very rare in a single commercial real estate building. Now, from a 3-tier IP architecture, that is where you would get rid of the supervisory device. You'd have an advanced application controller, and you would have that connecting to other IP controllers. And so you wouldn't really have a supervisory device. You'd have the advanced application controller, and it would be running graphics inside it. Most of the modern ones can. And then you would have ASCs, and you would have I/O. So how do you do this? Well, you would go to your mechanical plans. You would go and look at your equipment schedule. You would do a takeoff. You would understand which terminal units you have, which air handlers you have, which hydronic plants you have. You would then understand what I/O requirements you have. So I like to build out my I/O bill of materials first. Then once I have a complete bill of materials and I have that list of I/O, then from there, I like to go and pick my architecture type and pick my controllers. Typically, I'll pick my controllers and then I'll pick my architecture type. So to recap, commonly we have a 4-tier architecture. We have servers. We have supervisory devices, also known as building controllers in some specifications. We have advanced application controllers, also known as AACs, also known as IP controllers, also known as kind of those supervisory devices with I/O capability in some cases. And then we have application-specific controllers, which act as either a terminal unit controller, a rooftop controller, anything where it's specific to an application and you're not really going to be able to interchange it. You're not going to typically take a VMA controller, which is a VAV modular actuator controller. So it's a controller with a actuator built into it meant for terminal units. Not typically going to take that and put it on a rooftop. I guess you could technically if it's free programmable, but it wouldn't be a wise choice. And the same thing with like unitary control if you're doing a BACnet MSTP or BACnet IP integration into a rooftop controller that's on the piece of equipment. You're not going to take that controller off the piece of equipment and then go put it on something else. That would be not very wise. All right, so what questions do you all have about architectures? Let's take a look at the questions you have and let's dive through those. Feel free to type those into the questions box or into the chat box rather. Do realize there's a little bit of a delay in between you asking a question and me being able to respond. So I'll take a look. Looks like we got several people still in the live stream, so take a look at what questions you got and we'll go from there. Excuse me. All right. Give you a couple minutes to ask whatever questions you got. In the meantime, I'm going to step away and clean off this whiteboard real quick. Grab something to wipe down this whiteboard, clean it off, so you can kind of model out anything you all have as far as questions go. So this is your chance to ask any questions you got related to architectures. Feel free to ask away. Love to answer those for you. And I'll give you all a couple more minutes. I'm actually going to pan the camera over just a little bit. There we go. That's better. More centered. Well, if I were you and I had a question, I would be asking, when is the cutoff point between using a 3-tier and a 4-tier architecture? That's a common question that really trips folks up. When do we move from a 3-tier architecture with a dedicated supervisory device to having a server? Like, what is that kind of pivot point? And my answer has always been, when you have mandated reporting requirements, like if you're in healthcare, something like that, where you have to have 5 years of data for your reporting requirements, then that is a good time to move to a server. Also, if it is impeding the operations of the building, so for example, if you have an 18-story building with 18 building controllers, and every time the building operator wants to go look at a different floor, they have to log into a different supervisory device, that can definitely be impeding their operations. That would be a good time to go and look at potentially putting a server in play. So there's no hard and fast rule, but typically if you're going to go beyond 3 to 5 supervisory devices on a single site, it usually makes sense to have a server. Additionally, realize that you can pull, depending on the manufacturer, you can pull supervisory devices into another supervisory device to centralize graphics. That being said, there are limitations on that, so you'd have to refer to your manufacturer, but it's usually between 3 to 5 as far as the limitations go. All right, so not seeing any questions, so we will call it a day. I'll go and end the live stream. If you do have any questions, definitely go to the chat. I encourage you to check out our troubleshooting webinar, which will be available today at 12 p.m. Central Standard Time, Central Daylight Time. I'll put a link to that in the comments. It's a completely free webinar. I encourage you to join that. It'll be really fun. We're going to be diving through a bunch of different systems from a troubleshooting perspective. We're going to be covering the troubleshooting process. So if you haven't, by the way, make sure that you go back and watch the previous episodes on this, and it'll be really important for you to do that, because at this point we've been kind of following a path on engineering, and so a lot of what we've covered today is dependent on you having watched past episodes. All right, Bruce asks, do you need to change the network for proof of operations? Can you expand on that, Bruce? What do you mean, do I need to change the network for proof of operation? What would that mean? You give me a little bit of expansion on the question, and then I will be able to answer that for you. Let's take a look. Like I said, folks, there's a little bit of a latency delay here, so forgive me for that, but it's how live video works. Let me think through that question. See if I can figure it out while I wait for your reply. Do I need to change the network for proof of operation? I don't understand the question. So I'm not 100% sure how to answer that. I'm not going to make an assumption. But Bruce, you're a student of ours, so you can always hit us up in the live office hours. or if you provide further explanation to this after I end the live stream, feel free to go and do that, and I will answer that in the discussion section. All right, anyone else got any other questions? Let me know. And I'm going to switch back over to my computer real quick, and we'll go from that. Alrighty. To prove something is operating currently. So no, not really. There's not much you need to change as far as the network. If you want to know a I/O device is operating, then typically I will almost always recommend that you do a physical check to make sure it's running. If you are talking about a networked device, you can do like SNMP traps on it. You can always ping it, make sure it's up if it's an IP device. So those are two ways. If it's a MSTP device, it's keep alive and discovery should be telling you if it's down or up, as long as you don't have the MAC address wrong. So yeah, there's not too much stuff. Damper valves. Damper valves, you should go look at them. Damper actuators, valve actuators, you should physically get eyes on. So yeah, anytime you're going and doing physical troubleshooting, you should be looking at it. That's like the first thing you should check is the physical device before you go and check anything else. So, yep. Hope that helps. Alrighty. So we're coming up on 8:20. Give y'all a minute or two. Remember that these happen every Monday at 8 p.m. and every Wednesday at 8 a.m. So definitely hop into those. Give us feedback on what you'd like us to cover. I think the next live stream is going to be on... What's the next live stream going to be on? Let's take a look. What are you going to be on? Controller architectures, which we kind of went through, but we'll go through deeper in the next live stream. We'll talk more about the 3-tier, 4-tier architecture. We'll talk about multi-regional architectures, things like that. Can you use feedback? I don't trust feedback from damper actuators, because if the damper is off the shaft, then the feedback will be not accurate. It's not a large amount of data. No, it's not. Any I/O, anything from building automation, unless you're using a legacy system like circa 2010 and sooner or earlier, our systems today can handle any data that BAS data has thrown at it. So, yep. But yeah, next Monday we're going to be covering architectures. So we'll go through that. Perry says I look younger than before. That's because I've shaved my head. I actually need to go get a haircut. But my old man shaggy, like near balding head is trimmed down. So then I've lost weight. So yeah, the benefits of working for yourself, you can kind of make your own schedule. So yeah, good stuff. Feedback, like I said, with damper actuators, I don't trust that. I want to physically verify it, unless it's an end switch, and even then I don't necessarily trust end switches, but that's just my old school nature of wanting to actually get eyes on stuff. So it just is what it is. It's awesome to see all of y'all here. Good stuff. Thank you. I look forward to talking to y'all on Monday's next live stream. So thanks a ton, and take care.